Now we will move on to our next program, and that is unordered linked list folder. Go to this folder, and I have created a project in this folder, but for the moment I am copying pointing these files to open in the code blocks. Okay, first is linked list.h that we have discussed earlier. It's the same class, and then we have unordered linked list.h. We will discuss this header file now in detail. So this header file has a new class named as unordered linked list, and below below are the definitions of the member functions of this class, and that's it. So first of all, let's discuss its class members. So this is unordered linked list, the name of the class, and we are inheriting this class from linked list type class, and we are mentioning the type template. It means we can create this unordered linked list of any data type like int, float, or string, or even an object of any class. Okay, let's expand this class definition, and let's see its functions. First of all, the function is search. As its name implies, it will receive a search item, and it will find this item in the list and returns true if the item is found, otherwise false. Similarly, next is insert first and insert last and delete node. We have discussed these functions already in the linked list class, and then these are simple functions, and then we have its definitions. It doesn't have any variable members of its own, only function members. And let's see its definitions. First of all is search, and it will receive a search item. So while performing the search operation, we will simply visit each element of the list and will compare each element to our search item, and will find that it contains our search item or not. So first of all, for this process, first of all we will create a current node, and we will assign the first node to the current node. Okay, so the current is now pointing to the first node of the list. Okay, we have also declared a flag variable named as found, and we have set its initial value to false. If during the process of searching, if the search item is found in the list, then we will set this we will set true to this found variable, otherwise it will remain false. So we will check the value of this variable after the search process, is it true or not. Okay, okay, now let's see the loop. This is while loop, and it's simply declaring that while current is not equal to null pointer, it will run while the current node is not equal to null pointer. It means it will run through all the elements of the list, but there is another condition, and not found, while there is the value of found is equal to false. Okay, in this, during this loop, we will, if the item is found, we will set the value of found is equal to true. So if it's set if the value of found is set to true, then this loop simply will break. So it will not visit all the elements of the linked list in case the item is found. Okay, so in this loop, first condition is that if current info, the info part of the current node, is equal to search item, then simply we will set found is equal to true. On the next check of condition, this condition become false, and the loop will break. Otherwise, if the search item is not matched to the current node, then the current node will point to the next node simply. So this loop will continue to visit all the elements until it reaches at the end of the list, or it founds the search item. At the end of the search function, it will return the value of found, so it can be either true or false. Okay, next we have insert function. Insert function is basically, it will be used to add a new node. The insert function, as its name implies, it will insert a new node at the start of the list, before the first item. Okay, it will receive a new item, then it will create a new node of the node type, and it will assign the value received in the parameter to the info part of the new node, and it will make the link of the new node point to the first node. So in this line, after the execution of this line, the newly created node will point to the first node. Okay, it will placed before the first node. And next line, this dot first, this will declare that now the first node is new node, not the previously first node. It also increment the count value. One new node is added, and at the end it will check if the last node is null pointer. It means the list was empty initially. There was no first and there was no last. So on a new node, in this case, will also be the last node. Next is insert last. As its name implies, it inserts a new node at the end of the list. Okay, new node is created and the item value is copied to the info part, and the new node's link pointer is set to empty because it will be the last node of the list. And also we will check that whether the list is empty before the insertion of this node. How we will check? We will check that if this dot first is equal to null pointer, it means the list was initially empty. So our new node will not only the first node but also the last node, and we will also increment the counter variable. And if the list was not empty before this insertion, then we will point the last node to the new node, and we will declare that now the last node is our new node, and we will increment the nodes. And then we have delete node. In delete node, we will accept a parameter as delete item, and we will first of all we will find this item in the list, and if this item is found, then we will delete this node in the list, and we will adjust the pointers of the previous and the next node of the deleted node. So first of all, we will create a current node and trail current. Trail current is a node that will point the node before the current node. So it means if current is pointing, suppose, to the node number 4, then trail current will point to the node number 3. If current node is pointing to the node number 10, then the trail current will point to the node number 9. Simply, it will hold the address of the node preceding the current node. Then we have a found variable. As usual, we will find the item first. Then we will check if the list is empty. If this first is null pointer, then we cannot delete this from empty list. Otherwise, we first of all we will compare the first node with the delete item. Okay, we will compare the first node's info to the delete item. If they matches, then we will remove the first node from the list. How we will do this? We will simply point current to the second node, to the first node. Okay, we will simply copies the first node into the current node, and we will point the first node to the first dot link. First dot link represents the second node. So in this statement, the first node will now point to the second node, and the first node, the previously first node, will be skipped from the list, and we will decrement the counter, and we will also check if there was only one item in the list then we that we have deleted. Then now the first node will be null pointer, and we will also set the last to the null pointer, and then the node we have got from the previously first node from into the current node, we will delete this current node from the list, from the memory. And then this case was if the node to be deleted was the first node. If the node to be deleted was not the first node, then we will find it first. To find the node in the list, we also need the address of the previous node, of the node that we want to delete, because we want to change the pointers. If we found a node that match our item to delete, then we need the previous node of the deleted item so that we can adjust the pointers links. So first of all, what we will do, we will move trail current to the first node and current node to the second node, right? This first dot link represents the second node. Okay, now the situation is trail current is pointing to the first node and the current is pointing to the second node. So now we will run the loop, and we will do this until we reach the end of the list and the item is not found. Okay, this loop is similar to the loop that we have discussed earlier in the search function. However, there is a difference of trail current. This loop will run until the item until we reach at the end of the list and the item is not found. Here we will check the condition. If current node's info part is not equal to deleted item, then we will move trail current to the next node and current to the next node. It means if the initial value of the current node was second node and the trail current's value was first node, now after executing these statements, the current node will point to node number 3 and trail current will point to node number 2. It means both pointers are moved to the next nodes. This happens when the item is not matched. However, if the item is matched, then what we will do, will simply assign found to true. So next time when it goes to the condition check, it simply becomes false and the loop is broken. So after the loop, we will check that if the node is found, then we will adjust the pointers of the list and delete the node. Otherwise, we will simply print a message that item to be deleted is not in the list. So let's see how the item is deleted from the linked list. If the item is found, then okay, now what we have to do in this deletion process, we will point the previous node to the next node of the deleted item. So in this case, the current node points to the item to be deleted and current dot link points to the next node after the deleted item, and trail current points to the previous node. So what we have done, we are pointing the link part of the previous node to the next node after the deleted item. So in this statement, the deleted item is skipped from the linked list chain. And in the next statement we are simply decrementing the count variable, and then we see that if the node we deleted was the last node, if this dot last is equal to current, then we will adjust the last node to point to the trail current, the previous node. Okay, after the adjustments of pointers we will simply delete the current node from the memory.